When we talk about integration, one of the most important things that we want to make sure that we can keep straight is our notation. We've seen a lot of different new notation over the last couple of weeks, so let's make sure that we understand what it all means. Let's check out the first piece of notation, which came from week 10. This notation we've seen before. We have the long s and the dx, this piece and this piece go together, and then we're using this notation around some function f, right? So the function is sort of part of what we're doing here, and the long s and the dx together, so long s and some stuff and dx, really means anti-differentiate. We saw this in week 10 first, where I was asking you to do various problems where I just wanted to know what was the antiderivative of this function, and we use this notation. Another thing that some people often call this notation is the indefinite integral. So you may hear either of those names for this notation, right? All it really means is you want to anti-differentiate or find an antiderivative for the function. Our next notation comes from week 11. This notation is really similar to the last one, except this one has an a and a b on our long s, right? This one is called the definite integral. Definite integral. As opposed to the last one, which is sometimes called the indefinite integral. And the reason that this one is definite is that I have these a and b. So a and b are called my limits of integration. The a is called the lower limit, and the b is called the upper limit. Partly lower because it's lower on our long s integral sign, and upper because it's upper on our long s integral sign, and also because normally a is a smaller number than b, right? We talked about the opposite situation where a is a bigger number than b, but most of the time what you'll see is that a is a smaller number than b. And so we're going from this smaller value or lower value to this bigger value or upper value. Right? This definite integral, when you see this, we saw this first in week 11, and so the idea is you want to calculate the area under the curve or between two curves, etc. Right? We use the definite integral in a couple different ways in week 11. Right, and so this week 10 indefinite integral and week 11 definite integral are what we are connecting here with the fundamental theorem of calculus. Finally, let's introduce some new notation most often used with the fundamental theorem. This notation is partly old. Here we have the definite integral that we've seen before, and here we have some new stuff. Okay, so this f is an antiderivative for my little f. So this is actually a statement of the fundamental theorem, right? The long bar, like this, means evaluate this f, right? So we've seen the long bar maybe in week 2 or 3, somewhere along there, but we didn't really say too much about what it is. You'll see it all the time when people are evaluating definite integrals. Right, and all the bar means is evaluate this f. You want to make sure it's a big, long, tall bar so you don't get it confused with the number 1 or maybe an absolute value sign that's missing its partner. The long bar is decorated with our lower limit and our upper limit, and they're in the same place as they were before, lower limit on the lower part of the bar and upper limit on the upper part of the bar. And so if I put limits on it like this, this means evaluate this f at b and a and subtract. So in math symbols, f of x from a to b is the same thing as f of b minus f of a. Right? So you might say, why do we have this crazy notation for f of b minus f of a? Well, part of it is because usually when we're evaluating the integral, the thing that I want to do is write down an antiderivative. Then I put this bar to remind myself that I don't just want to know the antiderivative, I actually want to evaluate it at these 2 points. All right, so you'll see people use this notation when they calculate these integrals like this, and now you will know exactly what they mean when they write that. Good luck!